This is another tutorial for the TI-Innovator Hub and the TI-Nspire CX series calculator. This tutorial is aligned with the free 10 minutes of coding lessons available from the Texas Instruments website. In this session, we see how loops can be used to sequence a series of light pulses. Turning a light off and on might seem trivial. However, whenever you send a text, Snapchat, tweet, or any other digital communication, the chances are it got turned into a series of light pulses at some stage during its journey. So, before we get started on this lesson, we'll take a quick dive into some simple and not so simple ideas to help us understand what's going on. In the 1960s, computers started talking to one another, so a unified method of communication was needed. The American Standard Code for Information Interchange, or ASCII, was created. The ASCII code for A is the number 65, B is 66, and so on. These decimal values can be represented as binary numbers. Now I'll do the same, but this time I'll use light to represent the alphabet. The reason why light is an integral part of the communication revolution is due to optic fiber. Thanks to things like refraction and total internal reflection, a beam of light can travel long distances inside a cable. But not just one beam of light. More than 100 different colours, each carrying their own signal, can independently share their journey through a single cable. It's a bit like taking a single congested lane of traffic and spreading it out over hundreds of lanes. That's what light did for the communications industry. So, switching a light on and off, not so trivial. So that was Communications Engineering 101. Now let's get started programming. Connect the TI-Innovator Hub to your calculator. Create a new document and select Program Editor. Then New. I'll call my program Light 2. I'm also going to insert a spreadsheet application so that I can enter some data, and a calculator application to save me looking up the ASCII table. TI-Nspire has built-in ASCII commands. Type the command ORD and in quotation marks enter the letter or symbol for which you want the ASCII code. So capital T is the 84th character in the ASCII set. Capital I is the 73rd character. Now I need these in binary. I could convert them manually, but of course this is just base 2. So 84 is an 8-bit binary number equal to 0101 0100. 73 in binary is 0100 1001. Now I'll cross over to my spreadsheet application and enter all these ones and zeros into a list, which I will call data. With all of that done, I'm ready to write my program. My program will use a for loop. Starting with the first element in the data set, I need the program to loop 16 times. But I can be more flexible. I'll start my loop at 1 and finish it by using the dim command, where I'll look up the dimensions of the data list. That way, if I want to add more text, more ones and noughts, my program will cater for it. Now, my looping instructions involve an if statement. If the current data value is 1, then we need to turn the light on. Else, it must be 0, so turn the light off. That's a decision and action process completed. You can now try running the program, but that little LED light will blink so fast you won't be able to read it. So I'm going to add a wait command. I'll wait for 1 second between signals. That's all for this tutorial. In the next tutorial, you'll see how to generate the colours of the rainbow. Subscribe to our channel to receive updates when new videos are added to this series. Thanks for watching.